Okay, good morning. So let's see where we're at here. All right, so we're almost done with the first, I guess, the first third of the class, and so we got a couple things due Monday, which will bring us to the end of the first third, and then we'll have a couple new exercises next week, and then you'll have your spring break in the following week. So remember. Okay, so we'll meet both days next week, which are Monday, March 8th and Monday, March 10th. Then remember, both days occur during the spring break during week 7, so we will not meet because that's your spring break. So we'll have a whole week off here, and we won't meet again until March 22nd. So just make a note of that. I'm sure you already know when spring break is. Okay, so example 4.4, we did that on Monday. And then today, what I want to do is kind of go through a practice review test for the take-home midterm. And so we'll do some practice questions, we'll do a practice exam, and then I'll show you where your midterm, your take-home midterm is already posted. It's kind of like a longer compilation of all the practice problems that we've done at the end of the exercises, so you should be somewhat familiar with the types of questions. Yeah, and so we'll do a practice exam, go through that, and then you can let me know if you have any questions about the actual exam. But that's going to be due on Monday, along with example 4.4. Yeah. All right, so if you scroll down all the way on Blackboard to the Midterm 1 Spring 2021 section, I've got some resources here. I've got a practice exam with some solutions, and then the actual exam is right here. So we'll get to that later, but that's posted. That's going to be due via email, and so I'll make a note of that. But let's go through. Because I don't have. This is what I have planned for today. So I think it'll be nice just to go through a bunch of practice problems, just in case you have any questions for your actual exam. So let's go ahead and do that today. And I have my solutions here, but I think it'll be more beneficial if I just kind of go through them. So the solutions are here, but let's go through the questions and make sure everyone's good on all the types of questions for the exam. All right, so again, this is practice exam. You don't have to turn this in. It's already been, I've already have my solutions, and this is not the actual exam. But your exam is going to be very similar. You're going to have, let's see, 1, 2, 3, 4. Yeah, it looks like 7 questions, and they're all based on kind of the practice questions that we did after the exercises in class. Okay, so let's go ahead and go through this practice exam, and if you need me to repeat anything or you have questions on the solutions, then please let me know, because that's the agenda for today, is just to make sure you're good and don't have any questions on the take-home exam. Okay, so here we go. So practice question number 1. Remember this one for the bookshelf cost back on, this might have been day 1. Okay, so you got some information for how much board feet and how much labor you need, and how much the board feet costs, the percent increases, and also the cost of labor and how much that's going to increase. So the questions are probably asking about these blank cells here. So you have this information, and I just want you to know how to do it. And so these cells need to be calculated. So part A, what was the total cost for a cherry bookshelf in year 6? So remember that just composes the labor cost and the raw material cost. So okay, so the total cost is just the combination of the labor cost and the raw material, or the wood cost. Okay, and you can see that each board foot costs, right here, each board foot in year 6, due to inflation, costs $5.31. Okay, and make a note of how much board feet you need. You need 25 board feet for that. Okay, so 25 board feet at 531 per board foot, and then you need 25, or sorry, you need 5 labor hours at $28.15. Okay, so there's the cost of board feet for cherry, and there's how much you need, and there's the cost of labor, and there's how much you need. Now the total cost is the total cost for year 6. Okay, so if you were to put this in a calculator, you'd get something like okay, so $273.50 sounds right, and so that would be the total cost for the cherry bookshelf in year 6. Okay, so you can do the same thing for the oak bookshelf, and just know the difference is you need, it's a little more expensive for oak. Oak costs in year 6 with the inflation, $6.37 a board foot, but the labor cost is the same. It takes the same, uh, you pay your labor, there's no added skill in making a cherry bookshelf versus an oak, so the labor cost is the same. Okay, so total cost is a combination of just sum up both costs. Okay, the labor cost, the cost per board foot for oak in year 6, you can see that right there is $6.37. Okay, you need 25 of those, and then 5 hours or 5 labor hours. Okay, and this is the total cost. If you calculate this, you get something like $300 exactly. So that comes out nice. Okay, and then you can calculate the percent increase for parts C and D. All right, so what was the percent increase in cost for a cherry bookshelf from year 5 to year 6? So now that you have the cost, you can use those as the increase. So even if you get these parts wrong, still do the correct percent increase formula, because I'll still give you credit for that. So whatever numbers you got here, even if they're not right, use those for your percent increase answers. And so the cost of cherry went up from 269 to about 273 or 274, and the cost of oak went up from 295.66 to 300. Okay, so you can calculate the percent increase for both just using the general kind of percent change formula, which is just the change over the original, and then multiply by 100 to get that decimal in percent terms. Okay, so the percent increase is just the change over the original. So how much, take the difference between the new cost and the old cost and divide by the original. Let's say that okay, so we'll take the cost of cherry in year 6, take that, how that's changed since year 5, and divide by year 5. And if you multiply this whole thing by 100, that's how you get the percent change. Okay, so cherry in year 6, you calculate that in part A, that's 273.50. And in year 5, you have that in the chart, that was 269.39. Okay, if you divide that by the original or the year 5 value, okay, I get about 1.5%. All right, and then let's do the final one for year, what was the percent increase in cost for an oak bookshelf from year 5 to year 6? So do the same process for oak, and you can get the percent increase. And so just note that the change should be somewhere, so remember this increased at 1% and this increased at 2%. And so your, I guess, average percent increase that includes both the wood foot cost and the labor cost should be in between. So this is 1 and this is 2, and you got 1.5, so that sounds right. So if it comes out to something not comparable to these percent increases, then you might want to double check your calculation.
Wait, Professor,
Yes.
where'd you get the 273.5?
Oh, so we calculated that. So that's the value that goes here for year 6 for cherry, and that was the question you had to calculate for part A. So that's from right here.
Oh, yeah.
Okay. And so for part D, let's do the same calculation for oak.
Hey, Professor, when you get a chance, can you scroll up just a little? Yeah, thank you. Oh,
Here, I'll see if I can. There we go.
that's good. Thank you.
Yeah. Okay, and so oak in year 6 was what was it? We calculated that at that's 300 from right here. Okay, and it grew from in year 5. The cost in the chart is 295.66. Okay, so 300 minus 295.66 divided by 295.66 times 100 gives us a percent increase of, let's do this. All right, so that's about the same, which makes sense. That's about 1.46%, or same thing, 1.5%, but which makes sense because the both um, both the cost of board feed increased at 1% per year, and the labor cost increased at 2%, and so the average increase for the whole component of cost should be somewhere in between, which is exactly where it is, 1.5%. Okay. All right. Questions on question number 1? Okay, so question number 2 is, so just a side note, when you turn in your answer key for the take-home exam, you're welcome to do it like you can use the Word document and just type your answers after, or if it's more efficient, you can just write your answers on a separate piece of paper and just turn in. I don't need the questions with your answers, but you can leave it that way if you want. So you can just send me your answers with all your work. Um, or you can kind of do it like this. But if it's easier just to like comprise your answers with your work in a separate document, you can do that too. Or if you're doing it by hand, you can do it by hand on like graphing paper or just paper and just turn it into a PDF. All right, number 2, remember this one? We did the quantity discounts one. All right, so we have the books here, and you have a regular price, a leftover price, and you get a bulk discount based on how many books you order. Okay, and we're trying to decide how much to order based on this much demand. And so all we got to do here is calculate the regular price, the leftover price that we sell, and then the revenue, cost, and profit. So, well, I guess this goes with you have to do this along the way. So first, let's calculate revenue. All right, so revenue is a combination of how much revenue we get from regular price books plus leftover price books.
Hey, Professor, is this meeting recorded?
Yes, it is.
And where do you post them afterwards?
Oh, the videos?
Yeah.
So if you go on Blackboard and you scroll down to the YouTube link there, right
Gotcha.
here, and last thing on Blackboard after final exam is YouTube link.
Okay.
That'll take you to my YouTube page, and if you click on playlists, um, and this obviously this class is 272, you click on that, and they're all down here. So the most recent one is from Monday, right? Which is March 1st. So just click on whatever one, and I usually post them after. So this one will be available sometime like an hour or so after class.
Gotcha. Okay, thank you.
All right. So yeah, this will be posted. And right, okay, so revenue is the sum of the revenue from books at regular price and the revenue from books you get at leftover price. Okay, so let's first determine how many units we sell at regular price and leftover price. So this depends on quantity versus demand. So you can see that this is how much we order, and this is what demand was in this case. So we exactly ordered the right amount. So in this scenario, we're going to sell all of them at regular price because demand was exactly what we ordered. But if we order too many, then we have to sell the leftovers at the leftover price because demand was too low. Or if we didn't order enough for demand, right, then we can only sell what we order. So you only sell books at leftover price if you order too much, if you order more than demand. Okay? So if this number was bigger than this, the difference would be sold at leftover price because demand wasn't high enough. In this case, order quantity is 100. We ordered 100. We did it perfectly. And so we're going to sell all the books at regular price and nothing at leftover price because all the books were bought. Okay, so the revenue from books at regular price would be the regular price, $15, times how many books we sell at regular price, which would be 100. So we ordered 100. There was a demand for 100, so we're going to sell them all at that regular price. Okay, now I'll put this in here, even though it's going to be 0, just to be thorough. But the leftover price books are $5. But we sold all the books at regular price, so there's nothing left over. So this is going to be, we're selling 0 books at $5. All right, so basically our revenue is just 15 times 100, which is 1,500. Okay, now, all right, so we get to calculate cost, and the cost per book is based on how many we ordered, right? So you have to look at the chart and take the price that you're going to pay based on the chart. So okay, cost is just going to be the unit cost times how many books we ordered. Okay, so unit cost times order quantity, but you have to determine the correct unit cost based on how many books that this problem ordered. So the cost is, okay, so we ordered 100 books. So based on this chart, uh, can somebody tell me what the unit cost is? So what's the appropriate unit cost if we order 100 books?
$9.
Right, $9. So the unit cost tells you based on how many books you order in this column, what's the appropriate unit cost. So if you order less than 100, it's 10. If you order 100 or more, it's 9, which is exactly what we're ordering here. If you order 200, you get another dollar discount and so on. So if it's this number and less than the number below it, then you base your unit cost on that. So you can get it, every time you order an extra 100, you get a bulk discount. But in this case, we get this discount. If we would anything less than 200, we charge $9 per book. Okay, so 100 times 100, we order 100, and the unit cost is, the unit cost is 9 times 100. And 9 times 100, that's a cost of 900. Okay, so profit, once you've got revenue, once you've got cost, profit's easy. And again, show all your work and put the calculations in and the formulas, because if you were to mess up something and still calculate the profit with different numbers, I'd still give you credit for the profit. So you get partial credit. And so profit is just revenue minus cost. Okay, so 1,500 minus 900. Okay, so there you go. So part C is pretty simple once you get part A and B, but make sure you get how to determine how many books are sold at regular price versus leftover price based on order quantity versus demand, and also looking at the chart and what unit cost to charge based on the order quantity. So you got to look at the chart here, and you got to compare quantity versus demand to get how many books were sold at regular price and how many books were sold at leftover price. Okay, questions on this one? Everyone good on here? Okay, number three. Number three is based on the golf club demand, right? So we have different months of data. We have we have different prices that were charged for those golf clubs during those months, and then the demand for those golf clubs based on the price. So you have this data. I'm going to give you a scatter plot and a linear trend line, and then the parameters from this linear trend line. So here's demand, here's price, here's the linear trend line, and here's the intercept and slope associated with that. Okay, so using the parameters, write out the equation for the linear demand curve. All right, so you're just using a simple linear equation to estimate the linear relationship between demand and price. Okay, so it's basically Okay, so it's basically demand equals intercept plus slope times price because that's the linear effect of price on demand. All right, so just for your problem, just plug in the intercept of 211.59. The slope is negative. Okay, we got some. I think this is Carlo Andre. Do you mind turning off your volume? Or I guess I can. I'm gonna turn it off. Okay, so we're plugging in the intercept of 211.59, and then the slope is negative 0.34, so it's minus. Okay, so there's your equation. You're setting up the general equation, then plugging in the parameters. So it's demand equals this right here is the answer. Demand equals 211.59 minus 0.34 times price. So this is the linear trend line between price and demand. Okay, and then part B, what does the slope of the linear curve imply exactly? And so this number, or whatever it is in the problem, is the linear relationship between price and demand. So essentially, when price changes by 1 unit, this is how much demand changes, right? So you can see that kind of relates to the trend line. When price goes up by $1, demand goes down by how much? This much on average. So all right, so you can say that like that's the general way to say it, but specifically, this would mean that okay. So when price increases by 1 unit, which is $1, these are in dollars. Okay, then the effect on demand is it drops by 0.34 units. Okay, so there you go. The slope of the curve is the numerical impact on demand when price changes by 1 unit. And say what that means with these numbers. So on average, when price increases by $1, then demand decreases by 0.34 units, which are golf club sets, right? Okay, so does the law of demand hold here? And the law of demand states that when prices fall, demand increases and vice versa. So there should be, if the law of demand holds for a demand curve, you should have a negative relationship between price and demand and a downward sloping curve. So you can see here on this curve that when price goes down, demand goes up, and when price goes up, demand goes down. So that confirms the law of demand because we have a positive relationship between price and demand. Okay, so we have a positive relationship between price and demand, which also means that the slope is negative. See, the negative number means that there's a, sorry, this should be negative. Okay, so we have a negative relationship between price and demand, which means the slope is negative, right? So that confirms that demand goes up when price goes down and vice versa. Okay, any questions here on number 3 for the golf club demand? Okay, number 4, number 5 are based on, so there's a couple short, what are they called? Or present value or net present value questions. So we might have done a couple practice ones after that example. I can't remember which one it was, but the NPV one. So number 4, suppose the interest rate is 5%, and what's the future value of $100 10 years from now? So if your $100 compounds interest for 10 years at 5%, what's the value? Okay, so the future value is the present value times 1 plus the interest rate, and then raise that to how many periods it compounds interest. So basically, okay, so the future value is the present value times 1 plus the interest rate, raised to the n, and n is the number of years or number of periods it's compounding interest. So let's just plug in our terms. Right? You can use the general formula, and this is given in the practice problem with the study guides. Okay, present value is 100. Interest rate is 5%, which in decimal terms is 0.05. And this is we're gonna wait 10 years, so n is 10. All right, so make sure you raise that to the 10. So we get 10 times 1.05 raised to 10. All right, so I get something like that, about $162.89. Or let's say it's 163. Let's just round off. Okay, so how much of the future value is total interest? So obviously, if you started with 100 and you came out with 163 after 10 years, then you gain $63 in total interest. And then part C, by how much would total costs be greater at 6% than at 5% interest? So first I got to calculate the new value at 6% and then compare the difference in interest. So let's first do this for a 6% rate. All right, present value is still 100. Okay, the interest rate now is 6%, which is decimal terms 0.06. And again, that's gonna compound interest for 10 years. Okay, so if your future value is 100 times 1.06 raised to the 10, let's just start. All right, we get about $179. Okay, and how much would total interest be greater at 6% than at 5%? So that's just the difference between, you got $79 in interest here and 63 here. So the difference would be 79 minus 63. All right, so that's about $16. Okay, so there you go. Okay, so just understanding the future value formula and putting in interest rates and number of years. Questions on number 4? Okay.
Wait, Professor, where did the 79 come from?
Oh, so let's see. So this is the future value at a 6% interest rate. And then the interest you got here, starting with 100. So you went from 100 to 179. So the interest for this 6% rate was 79. So the question was, by how much would total interest be greater at 6% than at 5%? So at 6%, you got $79 in interest. At 5%, you got 63. So the difference is 79 minus 63. Right?
Oh, okay. Okay.
Yeah. Mhm. All right, so number 5. A disc jockey is contemplating the purchase of a new turntable that'll cost $1,000 and has a useful life of 5 years. The turntable will yield year-end revenues of these 500 in year 1, 300 in year 2, 100 in year 3, and 100 in year 4, and 100 in year 5. And then that's it. So after year 5, it doesn't give any revenues. But let's calculate the net present value of the turntable if the interest rate is 5%. Okay, so we did something like this, but the net present value is the sum of all the discounted values minus the initial cost. Okay, so the net present value is the sum. Let me see if I can. Okay, and remember you calculate present value by looking at the discounted future value. So for each term, it's the future value. Okay, there we go. Okay, so the net present value is the sum of all the future values discounted. So it's the future value in that time period divided by 1 plus I raised to the n. And then once you do that whole sum, subtract the initial investment costs, and then that's your net present value. Okay, so the NPV, so we have 5 terms we need to sum up, and then we'll subtract the investment cost. So the first year, you get $500. The future value is $500 in that year, divided by 1 plus the interest rate. The interest rate is 5%, so it's always going to be divided by 1.05. Okay, and then you're going to raise that to whatever period this is. This is year 1, so I'm going to put a 1 here. And then each year it's going to, like in the second year, it'll be raised to the 2, and so on. Okay, so that's year 1. How about year 2? All right. Okay, so in year two, you get $300 and divide that by 1.05 squared for year two. So the n here is whatever year you're in. So year one, year two. All right, let's keep going. We have three more terms. Okay. So in year three, you get $100. Divide that by 1.05 raised to 3 for year three, and then for year four. Okay, 100 divided by 1.05 to the 4, and then one more finally in year five. You get $100 divided by 1.05 to the 5. And then we're going to subtract the investment costs. And so the sum of all the future values is this here. So we got $500 in year one, $300 in year two. Okay, so this is year one, year two, year three, year four, and year five. And just divide those by 1 plus I raised to n, because this is the interest rate. And each year you have to discount it by a little bit more raised to that period, because the longer you wait, the less it's worth now, because you could otherwise put that money into some interest account that earns 5%. So that's why this number keeps increasing each year, because present value terms it's worth less because you have to wait longer. Now here's the sum of all the future value payments or stream of payments. And then the last thing we'll do is subtract the investment costs, because we want to see if this sum of discounted revenue is worth the investment cost. All right, so the investment cost is 1,000. Okay, so now you can put this in your calculator, or I'll do it. So sum up all these and minus 1,000 and see if you get a positive return or a negative return. Okay, I got about $995 for the payments, and then if you subtract 1,000, okay, you can see that it just wasn't worth. It came a little less than worth the investment cost. So net present value terms, $995 minus 1,000. All right, gives us about negative $5, and that's going to tell us we get a negative investment if we do this project. Okay, and so B, should the DJ purchase the turntable? And you can see that if the present value comes out negative, that means the $1,000 investment wasn't worth the payments we got in return. So no. Okay. All right. So questions on the number 5 question? How to do this one on the take home exam? Okay. Get rid of these. Okay, so 2 more. Number 6 and number 7 are both based on interpreting the listing the constraints, interpreting the shadow price after you calculate the objective. So remember this one, we had a little example or project where you sell basic computers and XP computers based on all the inputs, and you have a couple constraints, how much to produce, and the labor constraints, and you're trying to maximize net profit. All right, so you got most of the values. You're gonna have to calculate net profit and then answer some questions based on the constraints and the shadow prices. Okay, so now part A, given the current parameters, let's calculate the objective. So this is up here. So the objective is net profit, and your profit is the sum of what you get from selling the basic computers and what you get from selling the XP. So the total profit is the sum of the two. Okay, so your profit is based on the unit margin, right? This is how much you make per computer and how many you produce. So all the ones you produce, you sell, right? We're assuming a no inventory project. So profit for each type is number to produce times unit margin. So for the basic, you produce 100 and you can sell them at 235, or the unit margin per computer is 235. So you have 100 and you make a margin of 235 per computer. Okay, so 100 times 235 for the basic. For the XP, you make 1,000 and you get 485 per computer. So it's going to be 1,000 times 485. Okay, so if I put these together and get the total profit of this plus this, we get all right, I get 508,500. Yeah. Okay, and then part B, identify each constraint as binding or non-binding and calculate the slack, if any. Okay, so first I'll make a little column or chart and list the constraints. Note if they're binding or non-binding, and if they're non-binding, there's going to be slack. So let me set this little chart up. Okay, so first let's list the constraints. I think we have 4 of them. And so we did this in the practice problem, I think, after that exercise. And so we have a constraint for each inequality. So the number to produce of each type has to be less than or equal to the max sales for each type. So the first 2 are going to be number to produce basic, less than or equal to number to produce max sales, and the same for the XP. Okay, so that's the first 2. We have 2 more. The next one, they both have to do with the labor. So here's the, see, you have to you're basically describing what the inequalities or the constraints mean. So the labor constraint is labor for assembling, the hours you use for assembling have to be less than or equal to the hours you have available for assembling, and the same for testing. So we can't use more hours than we have available for each type of activity. All right, so we've got listed our 4 constraints. Now let's identify if they're binding or non-binding. And remember, binding means we used all of the resource we had available or all of the constraint. Non-binding means we didn't use it all. So you can see that the first one, we had 500, we only used 100, so that's non-binding. Okay, the next one, we had 1,000 to use, and we used all 1,000. So this is, we used everything we had. We could do up to 1,000. We did 1,000, so that's binding. Okay, for this one, we had 75,000 hours to use. We used all 75,000, 7,500. So that's binding. Okay, and the last one for testing, we were allowed 5,000 hours. We only used 3,100. So that's non-binding because we didn't use the whole allotment. Okay, and then finally, you're going to calculate the slack if there is any, and know that if it's non-binding, there's going to be slack. If it's binding, there's going to be no slack because you used everything. So non-binding and the slack for the first one is the difference between what was given or what was the max and what you used. So it's basically 500 minus 100. All right, the difference is 400. So the slack is 400. Okay, any non-binding situation, there's going to be no slack because you used all of what was given. So for binding, you should know that the slack is always 0. But the last one, we had a non-binding situation where we had 5,000. We only used 3,100, so the difference, 5,000 minus 3,100, is 1,900. Okay, and last thing is interpret part C, interpret the shadow prices in the sensitivity report. So you have one for the testing hours and one for the assembling hours. So you just got to interpret this 47 and this 0, and then you're done with this problem. Okay, so the 47 is the shadow price for assembling hours. Okay, so see how this is the labor available for assembling, and it shows you that we had 7,500 and we used all 7,500. Right, that should be familiar from here. So this shadow price tells us the value if we get one more hour for assembling, because right now we used them all, so another hour would be valuable, and the value is the impact or the increase on the objective. And so what this is telling us is that if we get one more hour for assembling, the value of that or the objective would go up by $47. Okay, so you don't have to write this whole thing, but this is the main part here. So if the firm gets one more hour for assembly and uses it to make computers, then the firm's net profit will increase by $47, which is the shadow price. Okay, another way of saying that is that, sorry. is the value to the firm of one more hour for assembling is $47. Okay, and you can see that there's a 0 here for this one, implying that this is a non-binding constraint. And initially we had 5,000 hours. We didn't even use we only used 3,100. So one more hour here is not going to help us at all, profit-wise, because we didn't use the initial 5,000. So the value of one more hour for testing, is 0. Okay, so the firm gets one more hour for testing. The shadow price is 0, so there'll be no effect on net profit. Profit won't change because the firm currently isn't using all of its available hours for testing. All right, so see the difference between if you get a positive shadow price, that's the value of one more of the resource. If it's 0, the value is 0, and you can say that. Okay. All right, questions on number 6 for the computers one? All right, one more. Okay, so we got one more on the last one we just did, which was on the gasoline heating oil example, where we're trying to maximize total revenue based on selling gasoline and heating oil by using these different types of crude oil to blend it to make the final product. So part A is given the current parameters, calculate the objective. And so remember the objective here is to maximize total revenue based on selling gasoline, heating oil, and any leftover crude oils. So there's 4 possible ways to make revenue. And I'll list those here. Okay, so you can make revenue from selling gasoline, heating oil, crude oil 1, or crude oil 2. So your total revenue is the sum of the revenue you got from all of those types. So revenue from gasoline plus revenue from heating oil plus revenue from crude oil 1 plus revenue from crude oil 2. All right, so let's just list how much we sold of each and the price of each, and that the sum of that is our total revenue. So the price of gasoline is $60. And we sold 20,000 barrels. The price of heating oil is $50, but we didn't sell any. So see how barrels sold 0? So it's basically 50 times 0. Okay, so for heating oil, for crude oil 1 and 2, let's look and see we didn't sell any of those. There's no leftover crude oil 1 and no leftover crude oil 2, but I'll put those in there just to be thorough. So the price of crude oil 1 is 45, and the price of crude oil 2 is 25, but we didn't sell any. So it's going to be 45 times 0 plus 25 times 0. So all the revenue in this current outcome is only from selling gasoline. But if you had values here, here, or here, you'd have to multiply those by the price and get the revenue from those other items. But in this case, crude oil 1, no revenue, and crude oil 2, but I'll put the prices and the quantities in there. 45 times 0 plus 25 times 0. Okay, so this is the sum of all the revenues, even though these three are 0. So the total revenue is just 60 times 20,000. All right, so, sorry about that. 1, 2, 0. Okay, so basically 1.2 million. Okay, so a few more parts for the last one, and then we're done. We got part B and part C on the constraints, and then the shadow prices. Okay, so let's identify each constraint as either binding or non-binding, and calculate the slack, if any. So we can use this similar setup from number 6. All right, so we have 4 constraints. So we have that we can't use more crude oil than we have available for each type, and then we have to meet the quality constraint for each type. So crude oil 1 used and crude oil 2 used have to be less than or equal to what we have available. All right, and then also we got to meet the quality. So the quality obtained for gas and heating oil have to be greater than or equal to the quality required for each. Okay, and then they're all. I think in this case they're all going to be binding. So you can see that we used all 10,000 here. We used all 10,000 here. This one we didn't use any of that, so that's 0. And even though this is not like, as long as this goes over that, then it's binding because if we use more than the required amount, then it's binding. So as long as the left side is bigger than bigger than or equal to the right side, then it's binding. So in this one, I think they're all going to be binding. Yep. Okay, and if they're all binding, that means that the slack is going to be 0 for all. All right, and then last thing for this one, let's just interpret the shadow prices for the resource constraints only. So just these ones for crude oil 1 and crude oil 2. Don't worry about the other ones because they have a non-interpretable shadow price. So we're only interpreting these two here, the crude oil 1 used and the crude oil 2 used, the 15 and the 35. Okay, so the 15 is for crude oil 1, and this is how much we had, and this is how much we used. So this is the value of one more barrel of crude oil 1, right? 15. Okay, and for the other one, this is the value of, the 35, this is the value of one more barrel of crude oil too. Okay, $35, because if we get another, that's the increase or the boost in revenue. Crude oil too, $35. All right, so both those statements kind of say the same thing in regards to the shadow price. So for the first one, the value of one more barrel of crude oil one is $15, the shadow price. And for the second one, the firm gets one more barrel of crude oil two and uses it in production. The firm's revenue will increase by $35, which is the shadow price. Okay. So that's the whole practice exam. Any questions on any of these types of problems? All right, so your exam is right here. If you go to the Midterm 1 Spring 2021 section, and we just did the practice exam. So there's the exam in PDF and Word document, and then here's my solutions already posted. But we went through that. So the solutions are there, and if you click on down here, Midterm 1 Spring 2021, there's a Word document and a PDF. It's both the same exact thing. You're welcome to use or refer to whichever one. Let me open up the PDF. Okay, so here's your take-home exam, which is due next Monday. So here's Midterm 1, BUS272, Spring 2021, and show all your work. It came out to 105 points, but it's still it's the same points as like a 100% assignment. And if you could put your answer sheet on a PDF or a Word document, that would be the preferred way for me to receive it and grade it. Okay, either one of those would be great. And you're going to submit this by email, all right? Not in the discussion forum, by email next Monday, March 8th. So you can email it to me beforehand or whenever. It just has to be emailed by next Monday. Okay, and you got 7 questions similar to the ones, or same type of questions with different numbers and different questions, but 7 questions here. You should be familiar with the type of questions based on the one we just did. Okay, so that exam, email me your answer sheet by next Monday, March 8th by email. And also don't forget that example 4.4 is also due Monday. If you haven't posted that, post that there. So you got example 4.4 and you got the midterm to do. Okay, so questions on what I want you to do for the midterm, or any questions regarding the take-home midterm? Okay. All right. Well, I think that's all I wanted to cover for today. I just wanted to go through that whole practice exam and make sure that everyone knows how to solve the problems. So get your take-home exam emailed to me by next Monday, and I think that's it for today. So everyone, have a good weekend, and I'll see you next Monday at the same time.
Thank you.
Thank you, Professor.
Thank you.
Thank you.
Thank you.